What number is equal to the square root of 9? So we're looking for what number multiplied times itself gives you 9, and that would be 3. What number is equal to the square root of 100? So again, we're looking for a number multiplied times itself that will give us 100. 10 times 10 gives us 100, so the square root of 100 is 10. Our next question, multiply negative 5y to the fourth times negative y to the fourth. So I'm just going to rewrite this. It would be negative 5y to the fourth times negative y to the fourth is the same thing as negative 1y to the fourth. So when we're multiplying these together, negative 5 times negative 1 is positive 5. In our product rule for exponents, whenever we multiply like bases, y to the fourth times y to the fourth, we add their exponent, and that gives us y to the eighth. Multiply 8w times negative 2w to the sixth. So I'm going to rewrite this again. A lot of times it'll make it easier for you if you express each variable as having an exponent. So 8w is the same thing as 8w to the first times negative 2w to the sixth. So 8 times negative 2 is negative 16. And w to the first times w to the sixth, remember, the base stays the same and we add the exponents. So 1 plus 6 is 7. Next, use the distributive property to remove the parentheses. So again, I'm going to rewrite this. 10z to the ninth times 9z to the first plus 4z squared plus 4. So when we're using the distributive property, what we're doing is multiplying that value that's touching parentheses times each term within the parentheses. So we start by multiplying 10z to the ninth times 9z to the first. 10 times 9 is 90. And remember, we're going to add exponents, so this would give us z to the 10th. Next, we multiply 10z to the ninth times 4z squared. So positive 10 times positive 4 is positive 40. And again, we add our exponents. So 9 plus 2 gives us z to the 11th. And last, we multiply the 10z to the ninth times positive 4. So 10 times positive 4 is positive 40. And we have our z to the ninth. Multiply the quantity v minus 8 times the quantity v plus 2. So I'm going to rewrite this as v to the first, you don't have to do this, minus 8 times v to the first plus 2. Now we use the distributive property here as well. So anytime we're multiplying two or more terms times one another, we'll start with the first term and multiply it times all the terms in the second group. So v to the first times v to the first is v to the second. Remember, we're adding the exponent. And v to the first times 2 is 2v to the first. So we multiplied the first term times both. Now we're going to take the second term, negative 8, and multiply it times both. So negative 8 times v to the first is negative 8 v to the first, and negative 8 times positive 2 is negative 16. So next we collect like terms, and there's only two terms that are like, and those are the ones that have the v to the first. So our v squared is unchanged. When we're combining our like terms, we have positive 2 minus 8, which is negative 6 v to the first minus 16. Now when we write our answer, we don't usually leave an exponent of 1. So our answer would be v squared minus 6v minus 16. Our next problem, multiply the quantity 2x minus 5 squared. So students need to understand that when we have something squared, a quantity squared in this case, what we do is we rewrite it as that factor 2x minus 5 times itself, in this case 2 times. So next we're going to use the distributive property again. We're going to start by multiplying the 2x times both terms. So 2x to the first times 2x to the first is 4x squared. 2x times negative 5 is negative 10x. So we've multiplied the 2x times all the terms in the second group. Next, we'll go to the next term, which is negative 5, and multiply it times both terms. So negative 5 times 2x is negative 10x, and negative 5 times negative 5 is positive 25. Our last step is to collect the like terms. So we would have 4x squared, and negative 10 and negative 10 give us negative 20. Notice this remains just x plus 25. Multiply the quantity x plus 6 times the quantity x minus 6. So again, we're multiplying 2 by 2. So we're going to use the distributive property, and we're going to start with the x and distribute it times both terms. So x times x is x squared, and x times negative 6 is negative 6x. Next, we take the positive 6 and distribute it times both. So positive 6 times x is positive 6x, and positive 6 times negative 6 is negative 36. So our last step is to collect like terms. That would be our x terms in this case. So we'd have x squared. Now notice what happens. Negative 6x plus 6x is 0. So we don't have a middle term. And then we carry our negative 36 down. Now, we're going to talk about conjugates later on. And this is an example of multiplying a factor times its conjugate. Here's some examples of other factors and their conjugates. 3x plus 2 times 3x minus 2. A minus 7 times A plus 7. Notice that the terms are essentially the same. They're just separated by opposite signs. Again, A and A, 7 and 7, minus and plus. Find the greatest common factor of 21 and 33. So what we're looking for is the largest value that divides into, in this case, 21 and 33. So there's a variety of ways to do it. One way is to find the prime factorization of both values, in this case 21 and 33. So 21 we can break down into 3 times 7, and 33 we can break down into 3 and 11. So 21 is 3 times 7, and 33 is 3 times 11. So we want to look for what factor or factors, plural, that they have in common. In this case, the only thing they have in common is a factor of 3. So the greatest common factor, in this case, is 3. So 3 is the largest number that can divide into both 21 and 33. So let's look at the next one. Find the greatest common factor of 9a and 6a cubed, or 6a to the third. So what we're going to do is look at the coefficients first, 9 and 6, and break those down into prime factorization. So 9 is the same thing as 3 times 3, and 6 is the same as 2 times 3. Now, 9 has a factor of a, and 6 has a to the third. So I wrote down a 3 times. Now I'm comparing to see what they have in common. They have 1 3 in common, and they have 1 a in common. So the GCF would be 3a. So 3a is the largest value that divides both into 9a and 6a to the third. Find the greatest common factor of these two expressions. 30 v to the fourth x to the fifth u to the sixth, and 12 v to the third x to the eighth. So again, we're going to start by breaking our coefficients down into prime factorization. So 30 I can start with 3 times 10, and then 10 can be broken down further into 2 times 5. And 12 can be 2 times 6, and then 2 times 3. So the prime factorization of 30 is 2 times 3 times 5, and of 12 is 2 times 2 times 3. So I'm going to come back to the variables in a minute. So when we're looking for common factors, they both have a 2 in common, and they both have a 3. So we would multiply 2 times 3 to give us 6. Now for the variables, instead of having to write 4 v's, 5 x's, etc., to be a part of the greatest common factor, the variable has to be in both. So they both have v's and they both have x's. So we know that v and x will be a part of our greatest common factor. But how do we determine the exponent? We choose the smallest exponent. So we have v to the fourth and v to the third. So the smallest exponent is 3. And for our x, we have x to the fifth and x to the eighth. So the smallest exponent is 5. So our GCF would be 6v to the third power x to the fifth.